Hi everyone, welcome back to our YouTube channel. In our today's video, we are going to discuss about advantages and disadvantages of quick sort algorithm. So let's get started. So let's talk about advantages first. So the very first advantage is it is it is easier to solve. Why it is easier to solve? Because it uses divide and conquer approach, which make this algorithm easier to solve. Correct? Then what is the next point we can write? It is efficient on large data set, right? It is efficient on large data set. Remember, if we talk about insertion sort, selection sort, these algorithms were not efficient on large data set because they used to do more number of comparison and all. But it uses a divide and conquer. So if you have a large data set, it can divide into small data set and does it, right? So with that also it brings what? It has low overhead also. This has low overhead also because and it only requires a small memory to function. If you remember that, log n for the best case and the average case and n for the worst case. So it has a low overhead. Then it is also cache friendly. Why it is cache friendly? As we work on the same array, to sort and do not copy data to any auxiliary array. So if you remember, there was one called as naive partition, remember, where we used to have a array, we used to iterate through array, and then we used to create a temporary array, correct? Then all the element less than that we used to put, then we used to put pivot, then all the elements greater than, and then we used to copy back. Remember naive partitions, but we were not doing, we were taking Horace partitions, right? So that is why it is cache friendly as we work on the same array to sort and do not copy data to any auxiliary space. We just swap, right? And it is also called as fastest general purpose algorithm. It is also called as fastest general purpose algorithm when we don't need a stability. That is why fastest general purpose algorithm because it works on the largest data set also, and we do not need it a stability here, right? There is one more thing about this. It is also tail recursive. Now, what you mean by tail recursive? I'll just explain you. So, if you remember when we were driving or writing the algorithms, right? So we were writing that quick sort, right? I'm just writing right. If this is there, okay. So j is equals to partition function we have written, right? Partition function, and then we have written that quick sort. You apply a recursive call from low to j, and then you apply quick sort from j plus 1 to high, right? This is what we were used to write a quick sort. Now we have written this partition. Now tail recursive is nothing but tail recursive means when the recursive call is the last thing we do. So after recursive call, did we do anything else? No. So tail recursive is nothing but when the recursive call is the last function or last operation in the algorithm. So that is why quicksort is also called as tail recursive. And there is something called as tail call optimization, which we can do. When you have such condition where in the algorithm the last operation is a recursive call, you can optimize it, right? So we can apply tail call optimization to it. So these are the some of the advantages of quick sort. That is, it is easier to solve, it works for large data set, it has low overhead, cache friendly because of less space, and fastest algorithm, and a general algorithm, and it's a tail recursive. And I have told you why what is called as tail recursive. When in any of the algorithm, last operation is the recursive operation, it is called as tail recursive. Now let's discuss about some of the disadvantages. I know some of the disadvantages are related to the worst cases, right? So you can write that. So it has worst case time complexity of O of n square, right? When we choose pivot element as a largest element or the smallest element. So you can write that the worst case time complexity is O of n square. Now, in case of small data set, in case of small data set, this is not recommended. Why it is not recommended? Because see, for small data set you have other options, right, which can do quickly. You just compare it and do it. You just need 2-3 comparison and done. But if you are doing quick sort for that, it becomes a time consuming algorithm, right? So for smaller data set, it is not that optimized or not efficient. Whereas for larger data set, yes, it is. Okay. Then it is not a stable algorithm. Okay. It is not a stable algorithm, meaning that if two elements have the same key, their relative order will not be preserved in the sorted output. Because why it will not be preserved? We are swapping elements according to pivot's position, right? Because you can write that the same order will not be preserved. Why that same order will not be preserved? Because what we are doing, we are swapping element according to pivot's position. Okay, I'm not just seeing what is coming next to it. I'm just saying if the element is less than pivot, put it in the left, right? That's it. That's why this is not a stable algorithm. Are you understanding these points, right? So if you understood the advantages and disadvantages of quicksort, please do like, share, and subscribe our channel. In our next video, we are going to discuss about applications of quicksort, followed by some examples and most frequently asked interview questions. Thank you.